So we are almost finished with section 2.3. So we have two more Venn diagram type examples and then Cartesian products, and we will be finished. Okay, so students at Heaven Gate High School, your book actually called it Hell's Gate High School, but I'm changing that. So students at Heaven Gate High School were asked if they were taking courses, algebra, biology, and chemistry. And so we're going to use this diagram down below to answer the questions, okay? So which region or regions represent students who do not, so they do not take algebra. So they're not taking algebra. So notice we have there's my algebra people, here's my biology people, and here's my chemistry people. Okay, see the ABCs up there? A, B, C. Okay. All right, so we want the ones that, what do we say? Do not take algebra. So here's my algebra people, all of those. So it will be everybody out here, right? All of these folks. So we're going to write down all the letters that are blue. So that looks like C and F and G and H, right? C, F, G, and H. I think that's all of them. Yep. So let's put that in there. C, F, G. What do we say? G, G, and H. All right. So that's everyone that did not take algebra. Now we want to find out everyone. Let's see. These are everyone who take biology or chemistry. Biology or chemistry. So let's come down here again. We'll get rid of all of this. So it's biology or chemistry. So here's my biology and here's my chemistry. So it's either or. They could take biology or chemistry. So that's all of these. So that's like a union, right? Everything. So that's B, C, D, E, F, and G. All right. So B, C, D, F, and G. Do we have E in there? B, C, D. Yeah, not E. Wait a minute. I'm getting my C's and my E's confused. Sorry about that. That's an E sitting there. There's my B, C, D, E. Oh, it's got C's. Sorry, it's got all of those. Let's try that again. It's got a B, C, D, E, F, and G. So it's got C and E in there. Sorry about that, right? B, C, D, E, F, and G. Yeah. All right. So that's all the ones that take biology or chemistry. Okay. So now let's find the students who took both by algebra and biology. Okay. Both algebra and biology. So here's my algebra. Oops, let me finish erasing the rest of that. So here's my algebra. And what did we say? Algebra and biology. So algebra and biology. So that's going to be B, C. Oh, it says both though, right? It says both. It didn't say or. It said both. So it's not going to be these guys, right? It has to be both of them. So it's only going to be those that are in the middle. It does not include these on the outside. So it's just those in the middle. So that is B and E because they have to take both of them. B and E. All right, so now they want to know, how would you describe region A? Region A. Let's look and see what A is. So here's region A. Just that piece right there. So that would be those that took algebra right? So they took algebra, but notice they did not take biology and they did not take chemistry. So they took algebra, but not biology and chemistry. Students who took algebra, but not biology or chemistry. Let's talk about F. How would we describe F? So notice that F is in B and it's in C. So they took biology and they took chemistry, but notice they did not take algebra. So they took biology, chemistry, but not algebra. Okay. Now they want us to describe region F using set notation. Set notation. Okay. So that would be that little part right here. Right? So I could do my intersection of B and C. So my intersection of B and C would be all of that, right? And now we're going to take out the A part. So then we take out just the A. So that's one way you could write it. Here's another way you could write it. B intersect C. So we still do that same part here. B intersect C, all of that. And now we're going to take out, or actually intersect with everything that is not in A. So that would be all of this outside of A, right? Everything outside of A. All right. So it would be everything in green, and then we intersect it with the purple stripes. Okay. So that would still give me this orange part. There we go. Okay. So let's go to the next question. If we were to combine regions D and G, so there's D, here's my D, and here's my G. I'm going to combine those to form one large region. So let's describe it using set notation. So notice that that purple is very close to being everything in C. Except what part did we take out? We took out the B part, right? We took out the B part. So we could describe that as C minus my B. You could also say C intersect everything that's outside of B. So that's, once again, we're going to have all of that. So that's this part, not B. And then we could do my C. So here's my C. I could do all of that. And so we'd say it's the intersection. So it's everything that is red and striped. So that would be my purple part. Okay? All right. It's not erasing. Or is it? All right. Let me get rid of all that. Okay. So now they want us to describe G. So let's see, what is my G? G is this part right there. So it looks like we have C, but we've taken out this portion here. We've taken out, and notice that's in A, and that's in B. So maybe my C minus my A and B. C minus A intersect B. That would not be A intersect B. That should be A union B, right? Because A union B, there we go. A union B would be all of, let me do it in green. A union B would be all of this, right? So I have my C, and then I take out everything that's green. So that would give me just my G region, just this guy right there. Okay. All right. Now this one is tricky. So go ahead and write trick. There's a trick you've got to know. Okay. So in an education class at Upstate, there are 40 students. 18 are also taking a math class. 5 are taking both math and biology. 8 are taking neither math nor biology. Holy moly. How many take biology but not math? Oh my goodness. So this is straight out of a textbook. Okay. So first I'm going to start off by saying we have 40 total. Okay. So you see that 40 is on the outside. So that means everything in the box, that's all education class. So that's all 40 students in that education class. Now it says that 18 are also taking a math class. So I'm going to say, okay, 18 are taking math. So I'll put it there. And it says 5 are taking both math and biology. So both math and biology. So that will be that intersection, right? Now let me ask you a question. Looking at the Venn diagram, the way I have it drawn, how many right now are taking math? Notice math is everything. So I would have to add those together, 18 plus 5. That's going to give me 23. Well, 23 didn't take math, right? They said 18 are taking math. So I'm going to have to tweak this a little bit, right? Because I only want 18 to take math, I'm going to change that. 18, I'm going to subtract 5. And now I have 13 in that outer circle. Does that make sense? 13 in the outer circle. So 13, should have done that in a different color. Let me do that in a different color so you can tell what I did. So I'm going to take the 5 out. So I've got 13. So I have 13 that are taking just math. 5 are taking math and biology, right? Okay. So now it says 8 are taking neither math nor biology. So 8 are not in either of those circles. So I've got 8 out here. Okay? Does that make sense? So 40 total. These 8 are not in a biology or a math class. Okay. So the question is, how many are taking biology but not math? So that is this one right here. I need to know how many are taking biology but not math. All right. Well, let's look at the areas that I have. Okay. So when I look here, I meant to shade it. So when I'm looking, let's use my green. Okay. So when I look, this covers all of this. So how many is that? How many students are in that section? That's what, maybe 18 students? So I've got 18 there. And then how many are, let's say, out in, let's do maybe orange, out in this area? Everything out there. That's 8 students, right? So that's plus 8. And everything is shaded except for the question mark. So 18 plus 8 would give me how many? 26. That gives me 26. So there's 26 that are out that are shaded. So I could say 40 minus 26 is going to give me not 24, but 14. So I have 14 in that red area, okay, in the question mark. I could have done it this way. I could have started at 40. Okay, so that's one way we could do it. Okay, another way we could do it is I could have said, okay, let me start subtracting. Okay, I've got 40. I'm going to subtract the 13 that's right here. So I've done that. I'm going to subtract the 5. I've done that. And I'm going to subtract the 8. So I could have done it that way, right? I could have said 40 minus 13 is going to give me, 27. And then I'm going to subtract 5. That's going to give me 22. Then I'm going to subtract 8. And that's going to give me 14. Okay, so there's a bunch of different ways that you could figure that out. But how many are taking biology but not mathematics? That's going to be 14 students. Okay, so notice what the trick is. Here is the trick. Okay, so whenever they give you an intersection, this portion right here, whenever they give you an intersection, you have to take that number 5 or whatever it is and take it away from here. And if we had something here, you'd have to take it away from that one as well. Okay. All right. And here is an example. This is from grade 6. So here is an example of Venn diagrams where they're talking about intersections and unions. Notice this Venn diagram for you guys that are taking geometry or will be taking geometry. It's a good Venn diagram to show you what is a square. It is a rectangle and a rhombus and a parallelogram. All those words, all those definitions you have to have, or definitions you have to have for geometry. Okay, last thing, Cartesian products. So Cartesian products are just pairs of elements from one set with the elements of another set that are paired up in a specific way to create a new set. Okay, so here's an example. Fred has 3 pairs of pants and 2 shirts. So we're going to show all the different possible pairs that we have. Okay, so here's his pants. He's got blue, white, and green. And here's his shirts. He's got blue and white. Doesn't matter if it's not a good looking outfit. Okay, so the Cartesian product, and you don't say P times X, even though this looks like a times sign, you don't say P times X, you say P cross X. So it's a Cartesian product. It can be also called a cross product. Okay, so we have all these different kinds. We could have, notice this is a blue pants and a blue shirt, so that's going to be blue and blue. Okay, here's blue pants and a white shirt. That's blue and white. Notice that the pants go first. Pants are first in this particular cross product or Cartesian product. So this one would be white and blue. White pants and a white shirt. Then this one is green. Green pants and a blue shirt. Green pants and a white shirt. So there's all the different Cartesian products. Okay, so that's Cartesian products. You can visualize those outfits. So when you teach Cartesian products, you want to do it, have something that is very visual for a student so that they understand that, let's see, let's find one that's the same. This one and this one is something different. White pants and a blue shirt is very different than blue pants and a white shirt. Okay, so those are 2 different things. So now we're going to do cross products with this set ABC and my set B, which is the numbers 1 and 2. So A cross B, notice what is going to go first, right? A cross B, the one that's going to go first is my A, because A is first. So that's first. So here are the cross products, okay? So I used, and I just, I like to do it like this. I'll take A first, and then I write all the different combinations that I could have with A. So that would be A1 and A2. And then I do the same thing. I get my B. So think of that as the pants, doing the pants. And then my shirts, 1 and 2. And then last, I'll do C. And then I do C1 and C2. So that is the cross product, or the Cartesian product, A cross B. So now let's look at B cross A. Notice what has to go first. My numbers have to go first now. So now I'm going to do the B first. So my B, let me get rid of that. So my B's are going to go first. So I'm going to do 1. So now it's sort of like having my shirts first. And now my pants, A, B, and C. And then I'm going to do 2. And then I have my A's, A, B, and C. Okay. Now, does A cross B equal B cross A? Are these sets the same? And by the same, I mean equal. I don't mean they have the same number of elements. I mean they are exactly equal. Okay. So this A1 is not the same as 1A, right? So these guys are not the same. No. So that means that order matters when you do cross products, okay? And if you think of this as a time sign, it will mess you up because times is commutative, right? 1 times 2 is the same as 2 times 1. But in cross products, 1 cross 2 is not the same as 2 cross 1. So order absolutely matters. So we have now finished chapter 2.